Today we're talking about some special factoring formulas. The goal is to factor a difference of two perfect squares and what's called a perfect square trinomial. So there are going to be a couple of special formulas that help us factor these things. So let's talk about the most important of these first. The difference of two squares factoring formula. If you have something of the form, let's say a squared, a is some quantity, a squared minus b squared. B could be some quantity as well. Turns out that that factors to be, anybody remember? I'll get you started. It's quantity a plus b times something else. A minus b. Now it looks familiar, doesn't it? Yeah, a squared minus b squared factors to be a plus b, the quantity a plus b times the quantity a minus b. Now, there's this idea of proof in science and math. Well, in particular in mathematics, there's an idea of proof where you can prove an idea and leave no doubt as to whether or not it's true. We don't do that a whole lot at this level, but we can do it with this formula. How can you verify any factoring formula? What could you do on the right side to verify that, oh yeah, a squared minus b squared really does factor to be a plus b times a minus b? What could you do?
Do it out.
Multiply it out, yeah. So the proof is to just take the quantity a plus b times the quantity a minus b and multiply it out. So what happens when you multiply out the first terms? What do you get? Well, you better get a squared. What about the outer terms? You're distributing a over a minus b. What do you get? Yeah, you can write the multiplication as a times b or b times a, but we usually go alphabetical order. So minus a times b. And then that's the outer. What about the inner multiplication?
It's plus.
Plus ab. And the last multiplication? Whoops. Yeah, I'll do it that way. B distributed over minus b makes a minus b squared. Now what happens in the middle here? Minus ab plus ab? They make 0 when you add them together, right? Anytime you add a number plus its opposite, you get 0. And then, of course, you're left with a squared minus b squared. And that completes the proof. So we'll just say we're done. Hey, we did it. So we proved the difference of two squares factoring formula. Okay? Not that you didn't believe me, but I just wanted to show you a proof because you don't get a whole lot of proofs at this level. So without a doubt, that's going to work. Okay. Example, factor. Part A, x squared minus 49. Here's another way to memorize that formula. Write it down every time you use it. I'm going to write it off to the side here. A squared minus b squared is equal to a plus b times a minus b. So the trick to using this formula to factoring the difference of two squares, first of all, you have to recognize that the given polynomial is a difference of two squares, or can be thought of as a difference of two perfect squares. In part A, x squared minus 49, what's acting like a? In x squared minus 49, what's acting like a? Not x squared, but just x, right? You don't have to, once you get good at this, you don't have to write a equals x. You'll just know it. You'll have it in your mind. But until you get good at factoring, write it down. What's acting like b? Okay, this is another one where the negative is taken care of in the formula. So you don't consider a or b negative, ever. Okay, when you're applying this sort of formula. So what would b be? Now b squared would be 49, so b is 7. You're essentially taking the square root of 49. Whoops, thinking ahead there. So b is going to be the square root of 49, which is 7. A is going to be the square root of x squared. What's the square root of x squared? As long as x is non-negative, x. Okay, so now just apply the formula. What's a plus b? Okay, so that's one factor. What's a minus b? X minus 7. And that's it. So in other words, x squared minus 49 factors to be x plus 7 times x minus 7. If you multiply it back out, you'll check and see it is, you'll get what you started with. You'll get x squared minus 49. In part B, we're going to factor 9x to the fourth minus 25x squared. And don't forget, you always want to look for a GCF, because if it's something other than 1, you're going to want to factor out that greatest common factor. And here, hopefully, you can see that we have an x squared as a factor in the second term, and an x to the fourth in the first term. So that contains a factor of x squared as well. So the GCF, the greatest common factor between the two terms, is x squared. And that's what we're going to factor out here. And then what's left after we factor out an x squared from 9x to the fourth? Well, just two factors of x, so 9x squared. And then if we factor out an x squared from 25x squared, we'll have a minus 25 left. And then the idea is, factor it completely. If it's not factored all the way, you have to keep going. And then hopefully you recognize that this factor, 9x squared minus 25, is a difference of two perfect squares. So how do I know that? Well, if you have a product of two factors that are perfect squares, believe me, it's going to be a perfect square. So you see 9, that's a perfect square. You see x squared, that's a perfect square. 9x squared is going to be a perfect square. So, okay, go ahead and write down your formula. Every time you use it, you'll have it memorized in no time. A squared minus b squared is equal to a plus b as a quantity times the quantity a minus b. And this formula tells you what to do. It tells you what you need. You need to identify a. You need to identify a. What's acting like a in this formula? Just look inside the parentheses right now. A squared is this guy. So what's a? Well, a is going to be the square root of that, or a square root of that. So what can you square to get 9x squared? Well, that's going to be just 3x. So that 9x squared is a squared, and this 25 is b squared. So what can you square to get 25 is your question. That's what will get you b. Equivalently, you could just think of the square root of 25. Either way, you get b is equal to 5. And you don't have to label these down after you get, you don't have to label these, I should say, after you get good at it. You don't even have to write them down. But until you get good at factoring using the difference of two squares, write it down. And then once you identify a and b, that's most of it. Because then you just plug into the formula, a plus b, and then times the quantity a minus b, and you're done. Don't forget to leave that GCF on the outside. So your final factorization is going to be x squared times the quantity 3x plus 5 times the quantity 3x minus 5. And that's it. That's your answer.